Hello and welcome back to my channel, students. As you all know, we are doing a problem series, and in this problem series we have already covered 19 questions, and the topics we have covered are basically belonging to general organic chemistry, where we have already taken up carbocations, carbene ions, resonating structures, aromaticity, anti-aromaticity, acidity and basicity. So now let us try to see what is there for us in question number 20. Now as you see the question on your screen, this question, after you have seen this compound, is based on basicity. We have done a few very good problems based on acidity. Now we are starting a new topic based on basicity. Now as you can see this compound, you have three nitrogens under scanner. You have three nitrogens under the name A, B and C, and as you all can see, all these nitrogens are having lone pair. Can you see that? Yes, all these three nitrogens have got lone pair. So before we come to this question, let me explain you what is the meaning of basicity. Student, you should understand it like this. For an example, if I take amine for an example, I have taken an amine RNH2. So if this amine you follow, you understand this nitrogen has a lone pair. And when I say the basicity of this amine, what I mean to say is, you can react this amine with some proton donor. Okay, so there is some proton source, and this proton source acts as an acid. On the other hand, this nitrogen, which is having a lone pair, it acts as a base. And how they react is basically a Lewis acid base reaction. By this we mean that the lone pair of nitrogen is given into the vacant orbital of H plus. In short, H plus takes up electron and nitrogen gives the electrons. So the one which gives electrons is called as Lewis base, and the one which takes up electron is called as Lewis acid. So we have in this question three nitrogens, as you can see, under the name A, B and C. These all are having lone pair, as you all can see, which can be donated to H plus. You have to assess, you have to see which nitrogen is more capable of giving the lone pair, which is less capable of giving the lone pair. The nitrogen which is more capable of giving the lone pair, the electrons, is going to be more basic. Okay, so that is how we are going to do the problem. Now, before we have proceeded, let me tell you. For an example, if I say there is a nitrogen with a lone pair and we are to check its basicity, we are to check its tendency to give electrons. So you should understand one thing. If I have more electrons, if the presence of electrons is more, then my tendency to give will also be higher. Because if I am not having the electrons, for some reason, for an example, these electrons are engaged somewhere, are invested somewhere, not available, less available. So if the availability becomes lesser, my tendency to give these electrons will also be proportionately lesser. So that is how you have to think. You have to think about the availability of electrons. Higher the availability, more the electrons are available, more will be its tendency to give electrons, and higher will be the basicity. So that is very fundamental tool we are going to implement while checking their basicities. Okay, so I will take up one by one. First I will check of A, then we'll come to B and C. So let us start investigating A first. If you see about A, then you realize that the nitrogen A is having a lone pair, and once its basicity is under test, you have to think about the availability of lone pair on that nitrogen. If the lone pair remains available on that nitrogen and it is not going here and there, then it will have more tendency to give. Okay, so that is how you should think. So for that, I was thinking, I was looking at the lone pair, then my eyes gone to the neighborhood of this nitrogen. My view gone to the neighborhood. Then I saw that, oh, this lone pair which is meant to be given and therefore the basicity of nitrogen to be shown is under threat. What type of threat? It is under conjugation. As you can see, lone pair, single, double. So how does this conjugation creates a threat to the basicity of this nitrogen, to the availability of this nitrogen, this lone pair on nitrogen? Then you should understand, since there is a conjugation, because of conjugation the lone pair will get delocalized, it will get spread, and as it gets delocalized, as it gets spread, as it engages somewhere else due to resonance, due to conjugation, it is not going to be available on that nitrogen. So once H plus comes to that nitrogen asking for electrons, this nitrogen says that, okay, you have to wait. Why you have to wait? Because the lone pair I had is basically roaming somewhere else because there was a conjugation, and for that the resonance happened and it went somewhere else. So it will show lower tendency to give electrons and its basicity will suffer in that case. It will be lower in that case. And as you have now seen that there is a possibility of conjugation, then you will as you see how it is going to get delocalized, this lone pair is going to go, as I have said several times, one position ahead. It will make a new pi bond, as you can see in the next resonating structure. As the electrons are going away from nitrogen, a plus charge will come on nitrogen, and as it goes, simultaneously these pi electrons are going to sit over this particular carbon, and these pi electrons now will be seen as a new lone pair on this carbon and a minus formal charge. So what has happened? The thing that has happened is your lone pair is now engaged and has gone somewhere else, and as H plus now comes to this nitrogen asking for electrons, it says I have lesser availability because electron pairs are engaged somewhere, and because of that H plus is now has to wait, and therefore it says to everybody that look, this nitrogen is not basic enough. So that is the point. Now you understand, once I have said that the lone pair availability is under check, under test, that the lone pair should remain available, more conjugation if it is present. For an example, what I am trying to say, you understand, as the lone pair gone away and the lone pair is now reflected at this carbon, you again find that there is another possibility of delocalization. How? Lone pair, single, double. So on that ground you can say that these electron pair will further delocalize, and as it further delocalizes, student, you will have to make that resonating structure, the lone pair one position ahead, and simultaneously these pi electron will sit on this carbon, and from here you will generate this structure. Now you understand, earlier the lone pair was here, then it hopped to this carbon, and then it hopped to another carbon. You understand? So 3 places it is spread. It is shared between 3 atoms, nitrogen and the 2 carbons. So if you are asking for the basicity of the nitrogen number A, you went there and you asked for the electrons, you will be you may not be getting the electrons because of the delocalization. And as you understand, more the delocalization, more the number of resonating structures you can form, more it will remain delocalized, remain dispersed, and lesser will be the availability. So you understand there are 3 atoms on which a single lone pair is shared. So you can think that on nitrogen the availability is going to be decreased. Okay, because the same thing is shared between 3. So one is going to get lesser share of that single lone pair. So the availability will decrease, and more the number of atoms which are going to share that lone pair, lower will be the availability on a single atom, that is nitrogen, under scanner. Okay, so you have to watch for the number of resonating structures. It should not be more for basicity to be higher. Okay, that is the point. So now for A, I have given you that there are 3 atoms on which the lone pair is delocalized. Now coming on to the case number B. As you ponder over the case number B, if you think about the lone pair on the nitrogen number B, you find that it is much available. The availability is higher. How? You understand there is no conjugation, and as the conjugation is absent, you understand, lone pair, single, single, single. I mean, there is no drama like, no song like lone pair, single, double. So in this particular case, the lone pair will remain localized. It will not be engaged somewhere else. And as the H plus is coming towards this particular nitrogen, this nitrogen says that you are most welcome because my lone pair is still on me. And it has happened because of the absence of conjugation, and you can easily take this electrons from me. So its basicity in this particular case is going to be higher, because basicity is all about your tendency to give electrons. So higher the availability, naturally more you will be efficient in giving the electron, more there will be availability of electrons to be given. So that is the point. Now coming on to the C option. As you see the option number C, again the same thought process comes to your mind, whether this lone pair is available or not. Then you finally see that, oh, the lone pair is in conjugation and there is a threat to the availability. How? Lone pair, single, double. Now as you see that this is a possibility, then you have to do the conjugation, you have to do the resonance. Because of this conjugation, you can delocalize these electrons one position ahead. These pi electrons are now going to sit on this carbon, and this carbon is now going to get a lone pair and a minus formal charge, and this nitrogen will get a plus formal charge from where the electrons are moving away. So as the hydrogen H plus comes to this nitrogen, so because you understand the lone pair is now engaged in resonance, the availability is going to get reduced. And you must think now that in the case C, the availability of the lone pair is decreased due to the sharing of lone pair, you understand. And it is shared between how many atoms? You can count. One lone pair you can see was here, one atom, and as you make this resonating structure, the new resonating structure, it hops to this position. So it is shared between 2 atoms. So availability on a single atom, that is nitrogen, is going to reduce by some percentage. However, you saw in the case of A, it was shared between 3 atoms. How? This nitrogen, this carbon, and this carbon. So if you, and in the case of B, you found that there was no conjugation, so there was a complete localization of electrons. So after you have gone through all this discussion, then you find that okay, now I'm in situation to predict the basicity. I found that in the case of A, the electrons were spread in, as I have made a slide, as you can see, I have clearly pictured out all the things. In the case of A, you can understand the lone pair was distributed over 3 atoms. In the case C, the lone pair was distributed over 2 atoms, and in the case of B, only single atom. So you understand, more you disperse the lone pair, more you share the lone pair amongst the atoms, lower will be the availability on a single atom. On that ground, now you can say that the most available is going to be the B, and therefore it can give the most. So the basicity of B will be the most. After B, now will come the C. Why? Because here the distribution, the sharing is lesser, so availability is more. So after B will come C, and the least basic is going to be the A, because there it was shared in amongst more number of atoms. So is simple thing. More, for an example, there is a football, you have purchased a group of friends, and you have decided to keep the football one friend one day. Okay, so more the number of friends, lesser will be availability of that football with a single friend, because you have to share the football amongst more. So availability is going to be lesser. That is how you have to think. And if there are less number of friends, then obviously a single friend, a single buddy is going to get higher share of that football. So more availability of football will be there with that particular buddy. Okay, so that is how you have to think about the basicity of nitrogen. Is very much dependent on the availability of the lone pair, and that is how you are going to think about these type of questions, and more questions are still coming in the future videos. So thanks for watching these videos, and I hope you all must be understanding all the basic fundamentals which I try to expose through these problems. Thank you very much.